In continuation with the previous discussion, we have here single tasking versus multitasking. As pointed out earlier, today's PC operating systems go way beyond basic I/O, and almost every resource in the computer has, such as the memory and the microprocessor, is managed by the operating system. And this is both good and bad. It results in a lot more consistency and a lot of added functionality. However, application programs can no longer directly access hardware in creative ways as they could before, particularly the MS-DOS and in early Windows versions. A good example is the chip used to produce sound. And this chip includes an electronic timer that can be accessed by external programs. And many older MS-DOS programs use this chip as a timer to halt program execution for a period of time. And one of the major reasons for giving operating system so much control over resources is to facilitate multitasking. And this is a technique that allows a computer to run two or more programs at the same time. And multitasking is typically achieved by splitting processor between or splitting the processor time between applications and switching so rapidly that the user is not aware of any discontinuity. And there are two general types of multitasking. The first method is known as the cooperative multitasking, where the operating system hands over control to a program, sits back, and waits for the program to hand control back to the operating system. And the other one is the preemptive multitasking. In cooperative multitasking, the assumption here is the program will do some work and then give control back to the operating system. If for some reason the program does not hand control back to the operating system, the program will hug the CPU until its operations are complete, while all other programs on the computer are on hold. If the program does not release control, for example, because it is stuck in an endless loop, the operating system may never regain control. As a result, no other programs can run until the computer is restarted. And this is an undesirable scenario. And this could also be a problem if some of the programs on the computer are time sensitive. If a program must collect data every second or regularly update a clock, a cooperative multitasking environment may cause trouble. And you will find this behavior in older operating systems such as the early Windows versions. Like if you print a word processing file and try to play solitaire at the same time, you will find that you cannot play a card until the print job is finished. And this is shown in this figure that first the OS gives control to the program 1. The program 1 performs some function and then returns control to the OS. Then the OS gives control to program 2. Then the program 2 performs some functions and then returns control to the operating system. And the operating system gives control to the program 1 and so on. So it shows the basic concept of cooperative multitasking. And a better method is the second alternative, which is the preemptive multitasking. Now, modern operating systems developed since the early 2000s use preemptive multitasking. And these systems include all Windows operating systems since Windows XP, along with the Mac OS X, and all Linux or Unix variations. In preemptive multitasking, the operating system is in control of the computer at all times. It lets program execute a little bit of code at a time, but immediately after the code executes, it forces the program to relinquish control of the CPU back to the operating system. It then takes the next program and repeats the same process. Because the operating system is in charge, it has a lot of control over how much of the how much of the computer's resources are allocated to each program. As a result, the computer must use more of its processor power and memory to support the operating system, but the behavior of programs and the computer as a whole are a little more predictable, like playing solitaire while printing a word processing file within a preemptive multitasking system is not a problem. And both processes get enough CPU time to do their jobs. And the user is unaware that the system has been rapidly switching between tasks. Now, the preemptive multitasking is shown is in this figure that we have the operating system here, which in controls of the computer's processes. Operating system is in control of the computer at all times. And we have three programs here, and we cannot we are not aware that the three programs are switching from time to time, and it's rapid. Some older operating systems, such as MS-DOS, were single tasking, and a single tasking operating system executes one program at a time. So, as you can see in this figure, to do something else, one program must be stopped, and a new program must be loaded and executed. Because multiple programs are not trying to use the same resources, single tasking operating systems are a lot simpler. And these systems are considered older technology, and as new operating systems are released, they are seldom single tasking. New single tasking um, operating systems are found only in computers with very limited processor capacity, such as the older personal computers, older personal digital assistants, which have long since been replaced by smartphones and tablets that support their own multitasking OS. A special note that must be made of a hybrid system called the task switching operating systems. And this system offers many of the device management functions of the multitasking operating system, and it can load multiple application programs at once. It will actively execute only one of these programs. However, if the user wants to use another application, he can ask the operating system to switch to that task. When the switch is made, the operating system gives control to the newly selected task. And obviously, many of the problems associated with switching among various applications and their use of various devices do not have to be addressed, making this a less complicated type of operating system than a true multitasking system. And this system is also considered an older technology that is not used in any of the new PC operating systems. And many earlier versions of Mac OS are task switching and are some of the operating systems found in much older PCs such as the Atari ST series, which focused on the home computer market. Now, this table shows the comparison between the single user and multi-user operating system. Some operating systems able to run multiple programs at the same time with multitasking technology, which allows multiple users to use an application simultaneously. And these systems are known as the multi-user operating system. And this multi-user system is almost a multitasking system. And most multi-user systems use preemptive multitasking technology. The desktop operating systems were designed as single user system with the exception of Unix and Linux, which have always been multi-user operating systems by design. And from the start, all Windows Server systems from Windows NT onward were designed as full-featured multi-user systems. Mac OS X Server is also a full-featured multi-user system. The desktop versions of operating systems such as Windows 10 and Mac OS X are also multi-user, but they do not have the full multi-user capacity of the server systems. And all of these desktop systems are intended to handle only 10 to 20 simultaneous users before they bog down under the load. The system is designed to handle hundreds of users at once. While modern OS are multitasking as well as multi-user, Windows 98 was a good example of an operating system that was multitasking but not multi-user. Windows 98 could handily run a word processing program while running a web browser and an email client for a single user, but it wasn't designed to run applications for multiple users simultaneously. Now, the current operating systems like the Windows 7, 8.1, and 10, Windows Server 2008, 12, and 2016, 2019, the different distributions of Unix or Linux operating systems, which focusing particularly on Fedora, which is used in as the leading edge development environment for the popular Red Hat Enterprise Linux. The Apple Macintosh, Mac OS X, the version 10, El Capitan. Now, at the time of this writing, there are three popular desktop operating systems were used most frequently in corporate America, and these are Windows 7, 8.1, and 10. And now we have already 16. And these three operating systems offer a stable work environment that is appealing for office use.